elements of the day to you all, ladies and gentlemen. We are Kandamko Robotics from Darama High School, all the way from Mashingo. I am Anasisha Zawanda, this is Brendan Jenamo, and this is Wilson Mugabe. And today we would like to present one of our most innovative ideas, which we believe will shape not only the future of robotics, but the future of smart and clean technology.
So you might be wondering, what do we have for you today? But before we dive into that, let us take into consideration what made us to create this innovative idea. We have observed that in Zimbabwe, there's a problem of load shedding, mainly as a lack of clean energy. So the solar systems which were installed to counteract the problem of load shedding are less efficient because they are fixed in a certain direction where they can't absorb all the ultraviolet rays because the sun changes direction. So this is our billion-dollar idea.
Ladies and gentlemen, we as Quantum Core Robotics have done a study at Darama High School and we've seen that the amount of energy provided by the solar panels in the morning alone is about 100 watts. The number which then decreases exponentially as the day goes by to as minimum as 50 watts, ladies and gentlemen. A problem which we believe is not only being faced by Darama High School, but different organizations out there who use solar panels. Now after observing this, we've come up with a brilliant solution which we call the green sunflower. Now, if you're a fan of sunflower, you might have noticed that in the morning, all the sunflowers will be facing in the east direction, but as the day goes by, all the sunflowers will now be facing in the west direction, following the sun. Our project matches that exact mechanism, improving the efficiency of solar panels, hence the name, the green sunflower. Now, ladies and gentlemen, in a nutshell, allow me to walk you through the anatomy of our device and what enables it to perform such a remarkable task. It has high light intensity sensors which detect where the highest light is coming from. It might be from the east, it might be from the west, or it might be directly above. This data is then fed into the microcontroller, aka the brain of the device. After detecting these changes, ladies and gentlemen, the microcontroller now controls the actuators which then move the solar panels in that particular direction. By doing the values are not only kept constant but by the maximum level, ladies and gentlemen.
So for customer segmentation, we have different sizes of solar trackers. We have small sizes, medium sizes, and big sizes, owing to the use. So others can be used for residential purposes, for commercial purposes, or for user utility. We have a single-axis solar tracker, and for future development, we have a dual-axis solar tracker. For more information, you can visit our Facebook page, Quantum Core Robotics.
For our future developments, ladies and gentlemen, we will integrate our solar tracker with advanced algorithms and machine learning to optimize energy production and predict weather patterns. This will ensure that we have maximum energy production. Also, since there will be maximum energy production, we need to integrate our solar tracker with energy storage devices such as batteries. Also, ladies and gentlemen, since there is increase in demand for renewable energy, it is most likely that most industries will shift to using these solar trackers because they harvest green energy. Thank you.
Ladies and gentlemen, as you can see right now, our solar panel is tracking light intensity. It is following the direction of the light intensity. So this is the same way it is going to function when it is placed to perform any task.